Okay, so now we're going to talk about trigonometry ratios. So if you look at a right triangle, we've already talked about how we have a right angle here, and the opposite of the right angle is, the opposite side is called the hypotenuse. Then we have a given angle. The opposite side of the given angle is called the opposite, and then the side that is next to the angle is called the adjacent. So we're going to use this information here to set up some ratios. So first we have the sine, okay, the sine of the reference angle, theta here, is a ratio of the opposite, I've color-coded it here, opposite over or divided by the hypotenuse. Okay, so whatever the opposite is divided by hypotenuse, and that's just that simple, just to set it up. The cosine is the adjacent side divided by the hypotenuse, and then the tangent is the opposite side divided by the adjacent. So we're going to try a couple example problems to see how this works. So first, this problem here, we don't know this angle, we just use the theta symbol. And we're going to set up what we have for sine, cosine, and tan. So before we set up our ratios in the same manner, let's go ahead and label what we've got. First of all, here's our right angle. The side that is diagonal here across from the right angle is called the hypotenuse, and we should probably label this as we go. So here's the hypotenuse, and then we have our given angle, theta, the reference angle. The side opposite that angle is 25. We're going to call that side the opposite. And finally, the side beside the right angle and the reference angle is the adjacent. This is going to help us set up our three ratios. So if we go back up here, the sine of theta is the opposite divided by the hypotenuse. So the opposite happens to be 25. So we're going to write 25 divided by the hypotenuse, which is 26. And this is the sine of theta. The cosine is the adjacent divided by the hypotenuse. The adjacent is 10. The hypotenuse is 26. And that's all we do there. And then finally, the tangent of theta is the opposite divided by the adjacent. The opposite is 25. And the adjacent is 10. And you just leave it like that. That's it. So here's the next example. This time we have a little bit of number, okay? And we have x for a side. That's okay. We can still use all this to set it up. So first of all of these are going to be 40 degrees. So not theta, but 40 degrees instead of the theta angle thing. So if you notice that on your packet, you just rewrite over it. Next, we have the sine, okay? And don't forget we need to establish our sides first. So here's the right angle. Always start with your right angle, which you already know. You already know this diagonal across from the right angle is always the hypotenuse. Always start with what you already know. Next, this is our angle, like our theta here. The side opposite this angle right here, remember go opposite, is 18.9. So this is the opposite side. And then x, this side right here, this one's going to be our adjacent. The side that touches both the given angle and the right angle. So now that we know this, we can set up our ratios. The sine of 40 degrees is going to be the opposite divided by the hypotenuse. So the opposite is 18.9 divided by the hypotenuse, which is 30. That's all you need to do. The cosine is going to be the adjacent divided by the hypotenuse. Adjacent would be x divided by the hypotenuse, which is 30. And then finally we have the tan, which is the opposite divided by the adjacent. So the opposite is 18.9